Hello and welcome to this Python tutorial. So in the previous tutorial we learned a very efficient way to evaluate our model performance. So that was about evaluating our model performance, and in today's tutorial we are going to learn a technique that is going to be about improving models performance. So we already built very powerful models, but we can still improve them. And how can we do that? Well, it's by finding the optimal values of the hyperparameters. Because indeed, any machine learning model is composed of two types of parameters. The first type of parameters are the parameters that are learned through the machine learning algorithm, and the second type of parameters are the parameters that we choose, like for example the kernel in the SVM model, or the penalty parameter, or even some regularization parameter in rich regression or lasso. And basically in any machine learning model we have a lot of parameters that are not learned, and so far what we've done in this course was just to choose one single value for these parameters. We never actually experienced with these hyperparameters. We never tried several values of them. And so that gives us still a lot of room for improvement, because maybe there were better choices for the values of these hyperparameters, a better choice than the value we chose. So this technique called grid search will answer to one of your questions that were asked many times in this course, which is, how do I know which parameter to select when I make a machine learning model? What is the optimal value of these hyperparameters? And grid search will give an answer to that, because it will find the optimal values for these parameters. And speaking of questions that were asked in this course, well, there was another very relevant question that was asked many times. It's, how do I know which model to choose for my machine learning problem? I have a machine learning problem that comes with a specific data set. How do I know which model to choose to solve my business problem? Which model would be the best one? Well, to answer this question, first, of course, what you need to do is know if your problem is a regression problem or a classification problem or a clustering problem. So that's easy. You just need to look at your dependent variable. If you don't have a dependent variable, then it's a clustering problem. And if you have a dependent variable, you see if it's a continuous outcome or a categorical outcome. If it's a continuous outcome, then your problem is a regression problem. And if it's a categorical outcome, then your problem is a classification problem. So that's the first step into figuring out which model to choose for your problem. And then the second step is to ask yourself, is my problem a linear problem or a nonlinear problem? And that is not an obvious question, especially when you have a large data set. You cannot figure out if your data is linearly separable, or if you would rather choose a linear model like SVM, if you're doing classification, or a nonlinear model like kernel SVM. And this question can be answered by the technique we're going to learn today, grid search. Because you're going to see that for a particular problem, well, grid search will tell us if we should rather choose a linear model like SVM or a nonlinear model like kernel SVM. So let's see how it will do that, and let's implement grid search. So we're going to work on the same problem as in the previous tutorial. That is, this classification problem where we need to classify the users in the social network and predict if they're going to click yes or no on the ad to buy the SUV. And therefore we're working with this data set, social network ads. And that's a good choice to illustrate grid search, because grid search will tell us if we should rather choose an SVM model or a kernel SVM model. And besides, that's a good example because the kernel SVM model has many parameters. It has this penalty parameter, this gamma parameter, and some of you asked me which values we should choose for these parameters. And so grid search will tell us exactly that. So let's do it. We are working in the same folder as in the previous tutorial, that is the model selection folder. Make sure that you have the social network add CSV file, and if that's the case, you're ready to go. So variable explorer, and now let's start to implement grid search. So basically, grid search can be applied after fitting your model to the training set, because one of the input of grid search will be the classifier here. So it has to be coded after this section. But then, since these three sections here correspond to evaluating the model performance, and now we are working on improving the model performance, so let's just put the grid search section right after k-fold cross-validation. First we evaluate the model performance, and then we improve it. All right, so new section here, applying grid search. And let's say to find the best model and the best parameters. Perfect. And now let's implement grid search. Okay, so first of all, let's import the right package, the right function for the job. And this package is called grid search CV. And we import this package from sklearn.model selection, because grid search is a model selection technique, so it's in the model selection module, and import grid search CV. All right, perfect. Package imported, and now let's move on to the next line, which is going to be about specifying the different parameters of which we want to find the optimal values. So I'm going to create this parameters variable, and that is going to be a list of dictionaries. So basically a dictionary in Python is actually a list of key identifiers, and for each key identifier it's given a specific value. And so the key identifiers in this dictionary are going to be the parameters that we want to optimize the value. And for each of these key identifiers, we are going to give it several values that are going to be the values that will be tested by the grid search model, and among these values the grid search model will find the best one. So you're going to see it will be much more clear once we build this parameters variable. So as I just told you, it is a list of dictionaries, and therefore since it is a list, we're going to introduce some square brackets here. Alright, and then inside these brackets we're going to input two dictionaries. So a dictionary in Python is put in brackets like this, and inside these brackets we need to input first the identifier. And what is the identifier? It's the parameter that we want to optimize. So what we're going to do now is actually select everything from the previous code section to the top. We're going to run this. Here we go. I'll execute it properly. And now in this kernel SVM model, we are going to press Command I or Control I to have a look at the different parameters and choose the ones that we want to optimize. So let's see, that's the parameters of the SVC class. And so basically when we built our kernel SVM model, we chose of course the RBF value for the kernel parameter, and then we just chose a random state value that is 0, but that's all. We didn't choose any other value for the other parameters. So for example, there is this penalty parameter of the error term. So that's a parameter for regularization to prevent overfitting. The default value is 1. That means that when we built our kernel SVM model, well, C was equal to 1. Maybe there is a better value for C, and that's what grid search will tell us. Then we have this kernel parameter. So we're going to include it in the dictionary as well, and that will answer to the question, what is the most appropriate model for my problem between a linear model and a nonlinear model? If grid search tells us that the kernel should be linear, then that means we should take a linear model. And if grid search tells us that the kernel should be nonlinear, like RBF for example, well, that means that we should make a nonlinear model. So we already know the answer, but what we're doing here, you can do it for your problems and your data sets. And so that will be very useful for you to decide if you should take a linear or a nonlinear model. And then we have degree. So we're not going to include that in the dictionary because we won't test if we should take polynomial kernel, because this degree is for the polynomial kernel function. And we're just going to try between a linear kernel and an RBF kernel, and therefore we will not try to optimize this degree parameter. But then we have gamma, which is a parameter for the nonlinear kernels like RBF, poly, or sigmoid. And so since in the different options of our model selection method there is the RBF kernel, well, we will try to optimize this gamma parameter and find the best value. So that will improve our model even more. Not only we will improve it by finding the best penalty parameter to prevent overfitting, and also we will optimize this gamma value to find the optimal kernel. So let's do it. Let's build those dictionaries that are actually going to be the different options that grid search will investigate, and among these options, grid search will find the best one. So first option is the linear model. And for the linear model, we have also a penalty parameter. So we will try different values of this penalty parameter. So the first thing we input here is, well, the key identifier for the C penalty parameter. And we need to input it this way in quotes, C, and then colon, and then we specify different values of C. So we specify these different values in square brackets. And so the default value is 1. And the more you increase this penalty parameter C, the more it will prevent overfitting. But be careful, you should not increase it too much, because otherwise you will get a new problem, which will be underfitting. That is a model that is so penalized that it doesn't fit anymore to the dataset. So we will try several values, like 1, so that's the default values, then 10, then also 100, and then we can also try 1000. But not more, because 10,000, for example, would be too much of penalization, and I doubt that we will get 1000, but we can still try. Alright, so that's it for the first key identifier, that is the first parameter. Now, comma to introduce the second parameter. And so right now we're testing the linear option, and so we're going to specify here the linear kernel. So to specify it, we first need to introduce the key identifier, and that is the parameter which is kernel, and then same colon, and then in square brackets we enter in quotes linear. Alright, and that's done for the first option. That is, the first option that grid search will investigate is a linear model, that is a classic SVM with a linear kernel, and for this model it will try to see what is the optimal value for the penalty parameter C. Alright, and now we're going to try the second option, which is the nonlinear option. And the nonlinear option is of course the nonlinear model, that is the nonlinear kernel. So let's do it. Same, we introduce this second option in brackets this way. And so same, we're gonna try different values for the C penalty parameter. So I'm copying that here and pasting it here. And then same, we take this second identifier for the kernel, we copy it and we can paste it here, but this time we are going to enter an RBF kernel, so that's for the nonlinear kernel. And what did we also say? We said that we also want to try several values for the gamma, that we need to optimize the gamma parameter. We will find the optimal value for the gamma parameter for this nonlinear kernel SVM option. And so let's input that here, comma, and in quotes, gamma, then colon, and then let's try different values. So which value should we try for this gamma parameter? Well, as you can see, the default value is auto, and if gamma is auto, then 1 over n features will be used instead. So that already gives us an idea of the range of values we should try for this gamma parameter, because how many features do we have? We have 2 features, so the values that will be used by default is 0.5. But that might not be the optimal value, so we're going to try other ones. And so let's try here some smaller ones. So let's pick the first one, 0.5, and then comma, and let's also try 0.1 and 0.01, and let's go down to 0.001. And if you're applying this code to your dataset, which you can totally do because it's exactly the same thing, well, since you will probably have a lot more features than 2 features, for example 100 features, you can even try a smaller number for the gamma parameter, like 0.0001. So I'm just putting this value for you, for your dataset, in case you need an even smaller value for the gamma parameter. So, and that's it. That's actually the second option that grid search will investigate. That means that it will investigate the option of a nonlinear model by looking at the kernel SVM model with an RBF kernel. And for this same option, it's going to investigate several sub-options, which are, different values of the penalty parameter C and different values of gamma. And so eventually what we'll get is a single combination of all this. That means that first we will know if we should take an RBF kernel and therefore a nonlinear model, or a linear kernel and therefore a linear model. So that will already tell us if our problem is linear or nonlinear. And therefore that already helps you a lot to answer your question, which model should I choose? And that, even if you don't want to build an SVM or a kernel SVM model, you can still apply this technique with the different kernels for SVM to identify if you're dealing with a linear problem or a nonlinear problem. And then, depending on the results, grid search will also tell you the optimal value for the penalty parameter C and the optimal value for the gamma parameter if it selected the RBF kernel. That is, if it found that the best option for your problem is a nonlinear model. Alright, so that's it for the first step of grid search. The first step is about choosing these options for the parameters. And now in the second step, we're going to implement grid search. And these parameters options are going to be the input of the grid search CV function that we just imported. So we will use this function and get the results of the optimal parameters in the next tutorial for step 2. Until